people watching the YouTube broadcast. And our first presentation today will be delivered by Alexey Semeniaka. And the presentation is on how to analyze historical ripe atlas data. Actually, I wanted to remind you that today we'll be using two languages, Russian and English. And not only can you listen to the presentation in the original, you can also listen to the translation. So if the presentation is in English, you will be able to get translation in Russian. And if the presentation is in Russian, then you can switch the channels and listen to the English interpretation. And the important thing is that you stick to the language that you've selected. If you're listening to a presentation in a particular language, then it's the same language that you need to use to ask questions. The channels are almost fully separated. So if you want to speak in Russian, please switch to the Russian channel. If you want to speak in the English language, please switch to the English channel. The channels can be switched between by choosing the relevant flag at the bottom of the screen. And I think that at this point, I can pass the floor to Alexey Semeniaka. Alexey, do you have the rights? Okay. You should be able to see me now, or at least my slides. Well, we can hear you, but we can't see you, though. Well, that was my intention. By the way, I don't think that if people saw my face, it will help them understand the material better. Okay, but I will disable my camera. Then, okay, let's start at the beginning. Dear colleagues, good day to all of you, and welcome. I'm very happy that we managed to organize an ENOG meeting, although in this very unusual by now format. Thank you everyone who has already joined us, and thank you to everyone who is going to join us in the next several hours and days. Today, I wanted to bring to you a topic that was or became relevant for me some time ago, and I will share my own experience. And every time when I talk about those things, I try not to use the resources or capabilities that wouldn't be available to a regular user. I'm trying to always, exist in a paradigm that is the same for anyone who is not an employee of RIPE NCC who doesn't have access to special developer interfaces. And sometimes when I do this kind of research, I bump into some interesting things. And there is something that I came across quite recently, and I decided that it might be of interest to many more people. You know that RIPE Atlas can be used in the active mode if you have a probe, and especially if you have an anchor by RIPE Atlas, then you can earn credits just because you have this device and it's enabled and it's integrated in the network. And you can use the credits to create measurements in the internet. I think that this idea is quite straightforward, and I'm sure that you've heard about it on many occasions. But all those measurements that are done by other people, by some people, they must be stored somewhere, and they are stored somewhere. And then when the question arises, what happens there and then in a particular geography at a particular time? If we know that somehow we can localize or locate on the network something that is curious, something that is of interest to us, the question arises: how do we get the data that is connected to this localized spot? Obviously, you don't need to create new measurements and you don't need any credits to spend them on something. The measurements already exist. The question is, how do we find them? How do we retrieve them? And it's a completely different objective. And the goal of this tutorial today, something that I wanted to share with you, is the experience of how to run the historical analysis on the data that has already been accumulated, because some measurements had already been done in the past. What are the techniques? What are the tools? And how can we prevent the errors that I made? How don't you, get yourself in the trouble that I got myself into if you wanted to, I don't know, analyze something that happened on your network or that happened elsewhere? What is it exactly that you should do? What are the steps that you should take? I want you to be quite comfortable in this environment and in this process. The code that will be presented in the tutorial is written on Python 3, and towards the end, I was using the BigQuery, the Google query language that is the derivative of SQL. Of course, you are not limited in any extent by those languages. You can use other languages, nothing will change. Really, for me, it was just easier to use Python. But they shouldn't set any restrictions upon you or everything. I mean, all of this is going to work even if you were to use a different language. Who might find this information useful? Well, the engineers who are running an investigation of what happened, or to a neighboring operator or to your own operator. And this is especially important for the engineers that for some reason could not generate active measurements themselves, and that could, in a simple manner, demonstrate what happened in the network. Of course, if you have your own measurements, then it's easier for you. You know where to get the data from, you know how to get the results. You have everything that you need to get the results out of the system. But if you didn't do the preparatory work, or if your own data is not sufficient, which is quite natural, it can happen, then this tutorial is for you. This tutorial is also intended for those researchers from the academia, from the academic world, who study the internet, who analyze what happens in the internet and why it happens that way, and what are the trends, and what should be expected. So this tutorial will also be handy for the researchers from the academia. And uh, this approach does not really require any cost on your part. You don't need to install any devices. You don't need to request credits. You just take the data that's already available, that somebody somewhere generated by establishing their own measurements, and you can make use of this data. And of course, this tutorial is also for the specialists who are investigating incidents, maybe not even internet related, or they are related to the internet, but that, that somehow involve the internet, let's put it this way, that somehow had an impact on the internet. Like, to give you an idea what I have in mind, take blackout, for instance. And this is one tool that you can use to do your own investigation, even if you don't have any special hardware, even if you didn't, set the scene in advance, just by making use of the data that has been constantly generated and accumulated and out of the already available data, you might perfectly well retrieve some meaningful information. Of course, I mean, um, I should keep this tutorial as practical as possible. That's why I decided to give you some cases, some examples that I find to be most typical for the three scenarios that I described above. So we'll start with a case when I have a list of prefixes. I know which network I'm interested in. I have an idea of the time frame when things were happening on this network, and I need to get the data about what was going on in the network at that time. And my objective is to get the measurements that somehow that somehow happened in and around those networks. The code that I'm going to share with you is, say, preliminary. It's simplified for a reason. It's very simple to give you an idea of how to approach this. In fact, if you do all of this as if you were an adult, as if you were a grown-up expert, then the code will be much more sophisticated. You will have to run uh, additional checks, and you'll have to convert data and this and that. But to demonstrate the proof of concept to you, I simplified the code to the best of my ability. Okay, so let's begin at the beginning. What is RIPE Atlas? For those of you who don't know, it is one of the largest, and it is one of the largest global data collection systems. It's one of the biggest RIPE NCC's projects. It is a global network of devices. They are called probes and anchors. You can get the device and place it on your network, or you can today use a virtual machine. You can just use a software probe. Each of these probes generate different types of measurements. There are many different systems, and that are used to protect the network of probes against it being turned into a botnet. The probes that are operational, that are connected to the network, they are used by other members of this system, by other participants, by other users, to generate their own measurements on your probes. I have a probe, I install it. This probe generates credits for me, but this probe is used as part of the global network. It doesn't really make sense for me to use a special device to do my own measurements. I can use my laptop to get the same results. But if I want to understand what's going on in, I don't know, India or Australia or Brazil, in most cases, there is no other way for me to get this information. I need a RIPE atlas or a similar system. The data that's generated as a result of those measurements are stored in a warehouse, and are your real, true big data that can be used by us or by other analysts uh, or experts to build additional tools on top of this data. This tutorial is about how you can be a part of this system and generate your own tool, or maybe even a tool for the whole community. The three cases that we're going to discuss today, the three approaches, are the ways to solve the problem that I have given you at the start of the presentation. We have an idea of the locality, we have an idea of the time frame, we collect the data about that locality and the time frame. And the first and the most documented approach is to use API. Obviously, RIPE Atlas has its own programmable interface. And there is a documentation supporting it. It can be downloaded from the website, and you can understand what is the sequence of requests that you make to get the data. There are some issues associated with the API. We'll discuss them later, but that's the first approach. The second approach is to use raw data, direct access to the storage. You can take the dump files, you can parse them, and you can get the required information out of them. Why not? This is a less documented approach, but it's quite functional, and we will discuss the pitfalls associated with it also a little bit later. And the last approach is the most recent one. It only emerged some time ago. There was an article at Ripe Labs from quite a short publication, which referred to a recent Ripe meeting that took place 2 weeks ago, really. So it's all fresh from the oven, and it's the approach that's based on big queries, uh, query by Google. We will take those cases one by one, and we start with Ripe Atlas API with the interface, which is the most standard approach. Unfortunately, and until recently, it was a bit awkward to use this technique. Why? Well, because only some time ago, the request that you made in the API did not filter in any way the measurement. How shall I put it? You couldn't filter without sorting through everything that happened. And if we're talking about a time period of longer than a few seconds, then the amount of data that you had to sieve through, that you had to sort through, was astonishing. And as a result, it was a lose-lose case. When the platform will have to upload the data that's 99.99% is not requested by the user, and then the user will have to, filter through all this data and find the jewels, the pearls that are of interest to the user. So we fixed that in September. And also when we work with a lot of data, Ripe Atlas has certain features that must be taken into account. It doesn't mean that these problems have no fixes, but it just makes the whole technique a bit more complex and complicated than we'd love it to be. In order to find a measurement that is associated with some prefixes, those measurements must either be launched from the probes that are inside those prefixes, or they must have an IP address as the endpoint, as a destination. That's part of those prefixes. So our problem splits into two. First, we need to find all probes inside those prefixes and look through the measurements that they all produce, because they are all part of the networks that we're interested in. And secondly, we need to see which of the measurements we're looking at the networks that we are interested in. So basically, we have these two subtasks. First, we need to identify the probes that might be useful, that might have value for us. So what we can do is, what you read here is this the query that's written in the last line on the slide. Unfortunately, by doing this, we'll not be able to get historic data. We will only get the information about the current probe. In my experience, it can be very different from how the network looked like a week ago. And in the small, quick trial that I ran, I found out that when I started my research, I saw about 20 probes in the networks that I got interested in, but the total number of probes that were associated with the measurements that I needed were about 50. So the difference was about twofold. Some of the probes were latent, they were dull, they were idle. For some reason, they were disconnected from the network, and there were about 30 probes that got online from time to time during the time period that I was interested in, but I couldn't see them now. So you wouldn't get their information if you're only using the current date and time. But this can be easily solved. The dumps of the active probes are uploaded into the files, and in the second line you can see the URL. So basically, for the time frame, for the date that you're interested in, you can download the files, and out of those files you will get the relevant information. I also wanted to remind you again, just to make it simple, January is just yet another cycle, but yeah, and not much will change, but for the purposes of this tutorial, to keep things simple, I'm going to take the 1st of November as my reference date, okay? And all the cases, all the examples I'm going to give today, they are all based on the assumption that we need the data as of the 1st of November. That is to say, from midnight until what is 11:59 p.m. on the 1st of November. And we are interested in just one file, basically, that can be found if you followed that link. In this file, you will find one big JSON object that can be parsed, and the list of probes can be retrieved out of this JSON. Its structure is very simple. There is meta data that describes what lies ahead, and then there is a list that's called objects. One element is one probe. And in here you can see the following fields: address v4 and address v6. If for some reason, I mean, again, to make things simple, there is also the essence, the autonomous system. In the fourth protocol and the sixth protocol, where this probe can be detected, where it is seen. So you understand what follows next? We need to parse this. Nothing complicated. I will not, obviously, interpret the code that you see on the slide. It just doesn't make sense to me. It's not the, well, it's not the last slide in the tutorial that contains code on it. I will just give you some comments about the code, and probably not for every slide. There is the green part that is related to our file operations. It's quite simple. There is the blue part, which is all about logic, and there is the yellow part, which is about IP addresses. To work with IP addresses, I use NetAdder because it's shorter and it's easier to code. And you can see that the code is very easy to read. The only thing that's probably worth pointing to is when you work with this file, do not forget that there are probes that might not have an IPv4 or an IPv6 address. We assume that a probe would have both, but probably it's a bit naive if there is no IPv4 or IPv6 address, then there will be a field there that will say no. And in the middle, you have to check. If not IPv4, you see, just add this check in there so that this code doesn't break or doesn't generate some unintelligible results. Okay, so basically, I think we understand what's going on. We take the file, we parse it, we get the list of objects, and then we check which of these objects have addresses inside the networks that we're interested in. So in those cases, it's 82.209 and it's 7.2.12, etc. So we have a list of probes. What can we do next? Well, after that, we need to get a list of measurements. And this is the logic on which the API is based. First, we obtain the list of IDs or identifiers of our measurements, and then for each ID, for each identifier, we obtain the results. It's a two-tier system, and I think it's important to understand if you get a description of the measurement, that doesn't mean yet that you have the results of the measurement. First, you get the list of measurements that you need, and after that, you extract the results out of the measurements. Again, you extract those results that pertain to the case at hand, to the information that you're looking for. Again, let's see how this is done. This is not rocket science. Again, we have an endpoint which has an important parameter, and this parameter was introduced in September. It is quite a novel thing that came into effect mm, just recently. So if you have some past experience of RIPE Atlas, probably you're not familiar with this feature because it just didn't exist before. Now we have it, and this for probes and enables you to filter out the probes that are relevant for you, that should be relevant with your results. So in this case, we have a list of probes. We will be happy with our dwell time. And we can use this parameter, as you can see here, you can see the code, in order to extract the identifiers of the measurements in which those probes were involved during the relevant time frame. Again, speaking about the time frame, the time range. We're talking about seconds relative to the 1st of January 1970. I take, I just take, I just, I just took the input for the 1st and the 2nd of November. So if you write code, that you should carry a function like from the calendar or date time uh, package to find this value for your relevant time frame. And we're interested in the measurements that started before the end of the time range and that ended after the time range began, because all other are left out or should be left out. So this is a bit inverted logic, but I show you the comments with those red arrows, and I also give you comments in words just to emphasize this. Don't make a mistake when you are coding. This is critical. So that's it. With a series of those queries, you make a list of identifiers that could be relevant for us. Definitely, they will have more measurements than we need. I can guarantee you that. So it means that later we will have to apply additional filters. But for now, we have a list of candidates. We have a list of measurements that most likely contain the results that we are looking for. Okay, now to the second subtask. Until now, we've been collecting identifiers of the measurements that are coming out of the networks that we want to investigate. And now let's take a look at the measurements that are made in the addresses of the networks that we are interested in. This is an old parameter. It's an old parameter of the same endpoint. and it's been around for ages, and you can use it directly via Ripe Atlas API. Or you can also engage Ripe Stat, and you can do basically the same, but with a different JSON. If you are using Ripe Stat somehow in your work, then maybe it will be a more familiar process for you. So we're looking at the same endpoint, it's just that the parameter is different. One parameter now is target IP. And we must use our prefixes to see what's there, what kind of measurements were done in uh, in in the networks that we know about. And the output is the identifier of the measurement. So we have two sets of IDs now, right? We have an ID from our own networks, and we also have IDs of measurements for our networks. We join these two sets of IDs, we bring them together, and then the final stage, we make a request to the new endpoint to return the result of the sole measurement. So you go through the IDs that you obtained, you make this query, and for every measurement that you have, you sort through the results that were generated uh, for it. It is also a lengthy process, but well, if you're not working with 0 but if you are, you've limited yourselves to some localized range of networks, then the previous filtering step will allow you to collect your results within a reasonable time. It will not take too long. Here you can check not only well, actually, I apologize. It not just DST adder, but also from. Why from? Because SMC adder is the address on the probe, and in the majority of cases, this is an address from 192.4, from some private range, from some private extension of which you know nothing, you don't know where it is, you know nothing about it, but you are interested not in the private but in the public address, and the public address is can be found in the from field. Okay, things that you need to remember about. Although you did this preliminary filtering, and you are no longer working with all the measurements that were generated throughout Atlas history, but you took some steps in order to concentrate to the maximum on the things that are relevant for you. Still, you might end up with quite an extensive number of results. The results are displayed on a page, and after you've received a chunk of those returns, of those answers, it's possible that something is missing, and you need to run an additional check to see whether there is more. And for this, we have a field called next, and all of this is described in the API. Documentation is something that you need to remember about. In addition to paging, you must also understand that the total number of objects also has a ceiling. And the blocks that those chunks that you are getting, in total, they will never be longer than 20,000 objects. So there is this limit. And if you have an idea that you've ended up with 20,000 objects, it is quite probable there is at least one more extra object that was not returned to you. And it means that you need to introduce additional logic that will enable you to bypass this limitation, so that when you're making a new request and when you get an additional 20,000 objects, you can still build your requests so that they can stack one onto another. This is a logic which you need to generate yourselves. It's a defensive mechanism of a ripe atlas, and it's an issue to some extent because you will have to code all this logic. You will have to make it part of your code. And if you expect to get a lot of results, it's inevitable you will have to do it. You must also remember that, say, you have many requests, you are requesting, and requesting, and some of those requests may not be returned because of the timeout. Something may be happening to the network. The controller might skip a bit. And if you are not monitoring the output, if you're not monitoring the results, and if you don't have the logic for rechecks, checks, you might not be receiving all of the data, or you might be getting wrong findings from your several-hour research. So it's another piece of logic that must be introduced in the code that must be part of your process. So please be careful and remember also to make pauses to leave some time between the repeated checks, because otherwise the system will just ban you. These are references. First link is the manual, and the second one is the formal reference that provides you with a description of all the parameters and endpoints. And you can also you can play with those parameters. You can enter a parameter. You can click a button, and you will see what kind of data it returns. And this is the first technique. It's best documented, but it's quite complicated. As you have noticed, you must be quite careful, and you must do a lot of preparatory work. For, well, those of you who are not, well, I wouldn't call you lazy, you are not lazy people, but if you need something quick, there is a different approach. Atlas data collects a lot of raw data. There is a lot of raw data. You can see for yourselves. You can see that in an hour we generate 1.5 gigabyte of information. This is a lot of data, and the results that we have for the past month can be found as dumps, as raw data at this URL, the URL that you are looking at on the screen. The dumps are split by hours. The directory is also split by days. The dump file is split into hours. And all these files contain raw information about all measurements that happened during this hour. There is also a special type of measurement that's called connection. In fact, it's not a measurement. Connection is how we see the probes coming online and going offline. Because sometimes the probe can get offline not only because of the blackout, maybe there was some disconnect in the network. So the probe is up, but it's not online. It's not on the network. So this pseudo measurement connection provides you with information of this kind. It is also useful, especially if you're investigating a blackout, for instance. The name of each file will contain the type of measurement, the date, and the time. And inside, you will see several lines. Each line is a JSON object. One result is one JSON object is one line. So if you want to look into the relevant network and the events that we're investigating if they place farther away than 1 month ago, you can take those files and parse them and see what happened. Well, sounds simple. And in fact, it is simple. However, there is always a But here is the but. Well, this is how it can be done. It could be done. The BZ2 Python module integrates nicely with the Relib library. You can URL lib library. You can work with a handler of the connection. Although there is some compression, we can still operate this handler as if it were a simple file. You read every line, you parse, you check. Well, unfortunately, as you have just seen, even in the archive, the files are quite big, and when you start parsing them, it turns out that it takes a lot of time. Well, of course, it depends on what it is exactly that you are parsing. It's possible that you are interested in certain things. If this is not the model that we are discussing right now, but you might be interested in some other things that can be easily retrieved out of this JSON, and you can just, go direct and work with those files directly without any headache. It is quite possible. But if you're working with complex objects, and IP addresses unfortunately are complex objects, it will get worse. And this is my real life example. One dump for 1 hour. It took me more than 1 hour to parse such a file. So an analysis for a week would have taken, I don't know, 10 days maybe, which is totally unacceptable. I don't even want to say that the network connection in which those blocks are generated once a day, little by little, it can just, you know, go offline. It can split off. Uh, there may be some, I don't know, some actions of the provider, and it would be so bad and unfair to lose the data that you spend hours on. So why does it happen? I try to understand where the bottleneck is coming to. BZIP2 is working fine. There is no need to optimize it. There is no need to get it even more complicated and rewrite it. Well, JSON could be faster. I mean, parsing could be. JSON library is not the super fastest library, but it's still peanuts. The main bottleneck is in IP addresses matching. That is to say, when we are checking whether the IP address associated with the network that we are interested in. So what do we do? How can we overcome this? This is my approach that I use. It's working. Uh, so first thing you can do is use regular expressions. We need to make sure that we're not missing something, that we're not dropping something that we really need. If some lines that look useful would be registered as useful, then that's all right. We will filter them out later. But if we identify something as not being useful and in the end it is useful, then that would be a much worse scenario. The /22 mask means that in addition to the first address that we have, and this is 185.179.80, we might also be getting 81, 82, and 83 as the third octet. So out of each prefix, we must retrieve all possibilities, all possible combinations of the signs that we might encounter. And after that, we can get straightforward and we can concatenate all these things together. You just join, you glue all these different options together. It works, but it's not the optimal approach. because you can have a lot of prefixes and concatenation that as a result slows things down. I don't know if you're talking 100 prefixes, then this can be a decelerator. Yeah, and from experience, it is quite a noticeable deceleration. I'll talk about it a bit later, but for now, what we could do is instead of checking all prefixes in parallel, when we are joining them mechanically, we could sort them out and we can build a tree. All prefixes that begin with 185 or that begin with 179 or etc. IPv6 prefixes. If it's 185, then all the prefixes below them, etc., etc. So basically, you get a logic, a nested logic in a regular expression. To do this manually is a lot of work. And this is prone with mistakes, with human error, when you're reinventing the wheel. But fortunately, there have been people on Earth before us, and you are now looking at the code on the screen, or rather a link on the screen that will get you code for regular expressions that you can take as is. It's a ready-to-use code. Just take it and apply it. This is how the code looks like. The only thing that's missing here is the procedure to prepare the regular expression. The trick is not in coding, but the trick is in normalization. I will go back. When we are converting blue addresses into green addresses, this is where the trick is. It took me a whole screen, so I decided not to show it to you. It turned out to be quite long, but here is a mask that we are teaching you when the mask for IPv6 that are shortened, um, or the masks that do not divide by 4. You have to treat them specially, and the resulting product is quite long. If you can produce a code for normalization, because I'm not really confident in the quality of my code, then it would be a major advantage. But in any case, it's things that you have to do with your own hands. But it's not that hard. If you do this homework, if you have your regular expression at hand, then you look at the lines in one file, several files, and then you check, you do a match. Is it a good match for the regular expression or not? If there is a match, then you need to do additional verification. You parse the JSON, and after that, you check the JSON and do whatever you intend to do in the first place. Again, this is all pretty straightforward. Um, it's simple. It doesn't require a lot of code. Apart from filtering the lines or filtering out the lines that we definitely do not need. If they are not IP addresses, then you just go and do it. If they are IP addresses, then they can slow down your process, like I said. So it would be better if you did this kind of pre-filtering, like the one that I have just shown you. And before I proceed to the next slide, this one, I'm trying to rewrite the not better module so that we could use normal uh, read operations for all checks so that it could be optimized for time. And maybe it will be a good solution for the problem. And if you are interested, then please write to me. At the end of the presentation, you will see my email address. And once I'm done, of course, I will post everything on GitHub. But after I'm done, I can send you the link to you directly personally if you are interested. Maybe it will solve the problem, and regular expression tricks will no longer be required. or at least they will become simpler. And the last topic for the day, this presentation is the third approach, which consists in using the big query by Google. It is our project. It's still in beta. There may be changes, and we ask you to be patient. I'm sorry. My apologies. We need a break in 10 minutes time. As far as I understand, 10 minutes. No, no, no. 10 minutes is fine. Well, maybe I will need, I don't know, several minutes more, but I will not take people too long. I will not keep them too long. So BigQuery, if you're not familiar with the platform, then I suggest that you familiarize yourself with it. Our data is already uploaded, and it's available to BigQuery users. And our guys wrote the manual, and you can see the URL on your screen. And this is an introduction on using BigQuery. It's a step-by-step procedure. Again, it's all very simple. First, you follow the link. And next to Ripe MCC Atlas, you will see the Ripe MCC Atlas in the bottom left corner. There, you generate a project and you give it a name. And I decided to call my project ENOG 17. So once again, Ripe NCC Atlas data is in the Ripe NCC Atlas project. So I suggest that you pin it for the future, that you always have access to it. And after that, you will see a huge white field where you can write queries. And just a second, I'm sorry. Yeah, in this field, you can write your queries. For queries, use an SQL-based language that uh, Google produced. And right now, data are uploaded mostly as is, with some exceptions. IP addresses have some type bytes. Well, IP addresses are bytes, so that you can use the functions of bit query to work with IP addresses. And start time has is of the timestamp type. Some useful functions. Regex, regular expression. You need it in order to work with your own data. You might need it to work with your own data that will interact with other data. Then the second function is converting string IP addresses into internal bytes. That's useful. You can also convert the IP address into a network address. This can be zeroed. And you can also put an expression to the given type. This is useful if you have a whole number, like a mask of the network, and you need to generate an integer. Bit queries, they also support tables on the fly by using with. And this is how it looks like. You write with, and then the name of your virtual table that's supposed to be created on the fly. Then as, then in select you first mention it. In select you first mention the field as net str, and then in all other lines except the last one, you write union all, and in the same fashion you can start taking action. As you can tell from the screen, on to parsing. All I did is cut and paste from somewhere, from some website. I did a cut and paste of addresses with IP addresses, and I used regex to select the first IP address then with another regex, I apply to the mask, I convert them, and then I have this visual table net split, which has net adder and net mask fields. And after that, I do select that returns the parsed results. And all this then can be applied to to and yeah, it's clear that with the same select, I can do the select into the right atlas of data uh, to retrieve uh, the relevant information. A virtual table is easy to work with. It's a quick solution when you don't have time for a more fundamental solution. However, in terms of time, this is still not very optimal. What can be improved? Our data can be stored in the BigQuery. We create our own storage, and this is important. This is probably the most important like, bit of the presentation. Um, in the region, you select EU because right now this data is stored in Europe, and Google BigQuery cannot work with data from different regions. So for data storage, you must definitely identify your region as EU. Then you upload your data, you identify the file format, and you describe the lines that are stored in there and how they must be converted to an SQL table. And after that, immediately after that, the data from this file can be found in the table that you can analyze with SQL. And things are becoming even simpler. We're working with the same lines. We're working with Ripe Atlas in order to find matches. We do inner join. This is the standard SQL procedure. And then the resulting table, you select the data that pertain to time period more than or less than, or it's up to you what kind of timestamp you are using, what kind of time filter you are using, and then you must also tell the system what kind of match you are looking for, how your data must be matched against the right data. And this code will do the inner join either by a DST address or SRC address to belong to a range that is set by your table. And still, even this approach is quite lengthy. To optimize parsing is not possible for Google. And the last step, and even more, uh, when you really need to save time, you convert your data by using insert into a different table where everything is already parsed, and then you place the same request using right atlas data and your table data, and you extract the measurements that you are looking for. Over here, as you can see, the result is ID of the measurement ID, MSM ID. This very last line, well, select MSM ID, and then the last line group by MSM ID. Okay, what are the pitfalls then? I set up a special account specifically for this tutorial. I have my own account, which is built, and I don't have any issues on the paid account. I don't have to pay much, but still, it's a cost. And for the first year, they will give you $300 for everything. And as far as I know, I've been talking to people, no one managed to spend $300 in a year. I'm still in the process. I haven't completed the quality yet. But with a free account, you'll be getting this kind of message maybe sometimes that, oh, sorry, unfortunately, you don't have enough resources. You have to wait before you can place this request. And this is a limitation that is set in the free account. IP chunk. Uh, it gave me warning that the 35 bit of the IPv6 address cannot be cut, and I was disappointed. I don't know what to do with it. IPv4 is fine. IPv6 um, creates issues. So basically, it's all very, very convenient and ready to use. But again, if you are concerned about the time it takes, then yes, I must warn you, it can take a while. It's not a magic wand. It's not free. There was one request that I placed, one query that I made during the experiment. I waited for a return for an hour and a half, and I had to just cancel on that query. So, and free account may not be enough. And the worst thing that I can say about the query is that only the timestamp for the start of measurement is stored. There are no timestamps for individual results. The results are there, but they do not have a data stamp. You do not know exactly when they were obtained, which is sad. I didn't have time to inform my colleagues about this. I will definitely file a complaint because this is a beta. This is beta. I can appreciate that, but right now the functionality is unnecessarily limited. Hopefully, they will fix it um, before going into production. You understand that there is no silver bullet. There is no universal, fast, and elegant approach. However, there are three different options. All of them, they have their advantages and deficiencies. API is the most mature technique and the most universal and the best documented approach to data analysis. And the code that you will write for API can be easily modified in the future for other purposes. However, uh, API requires a lot of coding. The logic is complex. And a researcher has to remember about all potentially challenging cases, like the number of results that are returned to you. You have to support the logic around them with cross checks and rechecks. I mean, you have to do a lot of preparatory work, and it means that you don't have really any other options. I mean, if you are using the API technique, you don't have other choice. So if your project is not a small one, you will have to spend a lot of time on coding and fine-tuning the code, and this becomes a project in itself. Working with dumps directly out of storage. The pros, it's easy to start. There is no entrance barrier. Logic is simple because everything is stored together. The results are there. You don't have to retrieve first measurement identifiers, then use those IDs to retrieve the results. No, the results are already there, which is easy. And also you see the files sorted by the hour. So you can go directly to the file that lies within your sphere of interest. But uh, this is quite a naive and a straightforward approach that can be very inefficient and that can take uh, enormous amount of time. Yes, it's the simplest technique. However, these files are only available for the data that was generated in the last month. And if you're looking for the data before 1 month, older than 1 month, then sorry, there is no such data. And the BigQuery, abroad. It's a powerful tool. It integrates easily with Microsoft products, with the spreadsheets, with the visualization systems. The capabilities are varied and versatile, and you can also work in a team. A team can be running the same project, and you don't have to do anything. Everything is ready for you to join uh, the team, the project. You can do joint research. But in order to make use of all these capabilities of the platform, you will have to work hard and study hard. Even the most basic things require your time to understand them, to master them, and you are also uh, uh, you are also facing the limitations of the free account. And if this is your work, if it's something that that earns your living, uh, probably you can afford paid access and use it. It's a good option, but I understand that not everybody will be able to do that. Will be able to afford it. And another thing that I think I've mentioned, the timestamp. We have timestamps only for the start of the measurement, not for the end of the measurement, and not for individual measurements. Probably this is because this is still beta, and I hope very much that in the future this will be addressed. But for now, it is a limitation. But the platform itself is absolutely fantastic, and I suggest that you go and see for yourselves. I don't think we have time for questions. But you see my email? No, we don't have time for questions. Okay, but anyway, on the screen you can see my email address. You can send me questions or comments or whatever ideas. Um, if you want to get in touch, Alexey, you see, Oleg Muravsky is our next speaker. Uh, his session is next, but his tutorial is shorter than yours. So maybe if you can stay for the beginning of the next session and people have questions, we can take some time from Oleg. Yeah, absolutely. I'm here and you can find me on the list of participants easily. Sure. So, okay, how about we start with questions to you, and after that, we will give the floor to Oleg. I wanted to thank all our participants. Uh, we will let you have a quick cup of coffee. Please be back at, well, in 20 minutes, half past. I don't want to say what hour it is because we're all in different time zones. For some of you, it will be uh, 3:30. For some of you, it will be 5:30. Anyway, in the next, I can see already a question that I can take. Oh, okay, good. But we're going to have Kahoot. Kahoot is a quiz now, and then half past on your hour, we will resume the conference. So please be back in 10 minutes um, to enjoy Kahoot and then the session. Thank you.
This quiz contains a large amount of cheese. Live broadcasting from the secure wallet of a cryptocurrency broker. Welcome to the first Kahoot quiz at ENOG 17. My name is Gerardo Viviers, and I will be your guide on this roller coaster of questions, answers, doubts, and drama. Oh no! Oh yes. So join us for fun and learning at www.kahoot.it or use the Kahoot app on your mobile phone. Don't forget to include your registration number and your nickname so we can contact you to send you your prize. We have some ENOG 17 t-shirts for all the winners. Today's quiz is sponsored by the letter Z, as in Z. So, and the theme today is Ripe Atlas. As you can see on the screen, the PIN code is 148365. Not a surprise, you can see it on the screen. So if you never played this game, let me quickly tell you how it goes. We're going to show you a question and then 4 different answers. The person who presses the fastest on the right answer will win. Yes! And the person who presses the slowest will lose. So get ready to press really quick, but you have to press, of course, the right answer. So now that I've explained the rules, let me start the game. I'm going to first, of course, put a little bit of music. So we have 19 players, and are we ready to start? In 3, 2, 1. Counting a little bit off. So let's see, for the first question, how many probes can you select maximum for a Ripe Atlas measurement? So, is it 2,000, is it 1,000, is it 500, or is it 1,500? Choose your answer. One of these 4 should be it. If you don't know, just press any button. It's all the same. So, the maximum amount that you can choose is 1,000. Remember that. On to our next question. We have Skef at the front, I'm not here, CGR, loading, and Boris 174. Very well. Ripe Atlas does what kind of measurements? Ow! Is it passive? Is it remote? Is it active or is it cosmic? Probably cosmic. Cosmic measurements. How far is that star? If you don't know, press any button. It's all the same. And we have the right answer, which is active measurements. Ow! And we have CGR taking the lead, Boris 174, RK93, Sergey M, and Ilya. Very well done, guys. And up to the next question. This is a multi-select. You can choose more than one. So Ripe Atlas software probes can run on a virtual machine, as a Docker container, on a dedicated machine, or do they have feet? All new probes can run at 50 kilometers per hour. Did you know that? It's all new. And the right answer is on a virtual machine or on a dedicated machine. Somebody was asking if they have feet. Warning. They don't. And we'll see Ilya at the front, CGR 201, Alex 243, and Boris 174. This can change at any moment. Let's go on to our next question. How many AESs are there on the internet? Choose the closest number. Thank you. Thank you. Is it that first number? Is it that second number? Is it the third number? Or is it 1 million? I can't read these numbers. They're so difficult. Is it 100,000? Yeah. There's 2 times 100,000. So I think we have to check this question. It's a trick one. In any case, probably mixed you up. Are you crazy? No, the question is crazy. Let's see. CGR at the front. Alex 243, Joe, Boris, and Ilya. On to the next question. What is the name of a traceroute tool in Ripe Atlas? So what is the name of a traceroute tool in Ripe Atlas? Tracemon, money trace. Traceroute or it has a name? Huh? Let's see. What do you think? Tracemon, yes.
Yeah!
Yes.
Yeah!
Yeah, he says. And the tables have turned. Joe at the front, Boris 174, AI 281, Ilya and 201. Let's go on to the next question. This is a long one. What is the cost right now to schedule a ping to your network from 50 probes around the world every 5 minutes?
Oh!
Yeah, that's a difficult question, eh? If you don't know, just press any answer. You will know the answer at the end. So was it a fortune if you haven't signed up for the math working group? Is it 1 million credits per month? Is it 1,3 million credits per month? Or is it that ping measurements are free? Well, the real answer is 1,3 million credits per month.
No!
Yeah, that's a lot of credits, but it's for a good purpose. And the tables have turned again. CGR taking the lead, coming in from behind. Joe, Boris 174, AI 281, and Ilya. And up to our next question. How much does it cost to use Ripe Atlas to ping your network? So how much does it cost? There's a credit system and you can earn credits. It's free for everyone in the Ripe community. It's free for all Ripe and CC members, but other RIRs must pay. Or is it free for all of those that sign up to the MAT work group? Let's see what you think. The right answer is there is a credit system and you can earn credits in several ways. So that's how much it costs. You have to use your credits. Let's see if the tables have turned. Neo, CGR is still at the front. Ilya coming up. AI 281, RK 93, and Joe. Up to the next question. DomainMon allows you to monitor your DNS records, your cholesterol, your name servers, or your domain names. That's a trick question, isn't it? Does it allow you to monitor your cholesterol? That would be kind of cool, right? In any case, it allows you to monitor your name servers, not your DNS records. You don't monitor your DNS records, but actually the performance of your name servers. So on to the next one. Let's see. RK93 taking the lead now. CGR, Ilya, AI, and Sergey. Anybody can win. This is only 2 more questions. So, Ripe Atlas can blank a server from several probes. Can it ping it? Can it reboot it? Can it sniff it? Or can it trace route it? Again, this is a trick question. Choose the right one. Well, the right ones, I would rather say. And the right answers are ping and trace route, both of them. So if you chose one of those, you got it right. And the scoreboard sort of remains the same. RK at the front, CGR, Ilya, Sergey, and AI. But anything can happen. Everybody's really close. On to the last question. Let's see. What is the point of measuring the internet? Why would you measure the internet? Because it's fun. We need to know how far until we're there. The internet demands to be measured, or we need to know if it's working okay. What would be the right answer? We need to know if it's working okay. So that's why we measure the internet. And on to the final results. At number 3, we have Sergey. Number 2, we have CGR. And number 1, we have RK93. Yes! Congratulations. We will contact you very soon somehow to get you your prizes. So thank you everybody for participating. I hope everybody had fun and maybe learned something new. I will be back tomorrow again at the same time and the same place. See ya!
Hello, everyone. I suggest that we go back to the second session. Well, not go back, just go to the second session. To the left of the screen where you are getting the presentation of the videos, you can see a list of participants. And at the very top, you can see your own name and a microphone yellow hand next to it. If you press this button, you will get into the line of those people who want to put their question with their own voice to the speaker. So when your turn comes, your microphone will be enabled and you can ask your question. But if you don't want to talk to the speaker, you can go to the chat and there is a little tab with a question mark in that. So if you don't want to speak, then you can send us a question in writing. We will read the question and the speaker will take it. Don't be afraid to send your questions in writing. And don't be afraid to ask to take the floor. And now let's ask Alexei Semeniaka to answer the questions that people sent us or wanted to ask during his presentation. Hello again. I only saw one question. And the question is, are all measurements public? It's a good question. In fact, the measurement has this attribute, public, non-public. Not all measurements are public because some measurements, well, some researchers, when they are producing a measurement, they will label it private. But to tell you the truth, those cases are extremely rare. Statistically speaking, we have the measurement like data, and so we know that the predominant majority of those measurements are public. And that is why this is the reason why you can use the tools that I described. Obviously, you will not be able to have access to private measurements. So that is the answer. Yes, there are some not public measurements, but they are few enough so that we can neglect them. But yes, if you're setting up your own measurement, you can also make it private. Oh, I don't know, maybe you can send people a link to the tutorial. Because we've had those level tutorials in the past, and there are tutorials online, and I'm sure that they contain all the basic information about the tutorial. Can you, can you do that? Yes, sure. I think it's a good idea. Of course, I can do that. It will take me some time to look around and find the best materials. For LIRs, for local internet registries, we have a special RIPE Atlas training. So you can book a training. Actually, your trainer can turn out to be Gerardo, who hosted our Kahoot today. So it depends. The trainings, they depend uh, depend on the audience very much. If the audience is boring, then the training is boring. I'm sure that today's audience is not boring, not at all. Okay, so since we don't see any other questions, I think that we can pass the floor to Oleg. Thank you very much, Alexei. Oleg, I can see that you are ready, and the stage is yours. And colleagues, be ready with your questions. So either take your turn to ask your question to the speaker, or send us a question through the chat box. Oleg, your microphone is off. You need to turn on your mic. Is that better? Yes, much better. Very good. Hello once again. My name is Oleg Muravsky, and I work at RIPE NCC. I work in the RIS, the RIS project. That is, say, I collect and analyze data that is later used as input into RIPE stat, the data that we collect and that we publish as part of RIS, and how this data can be used as part of RIPE stat is the topic of today's tutorial. We plan several demos. That's why I will disconnect my camera so that we ensure the bandwidth for us. I don't have many slides, but I will be sharing some videos with you anyway. So, okay, what's the content of this presentation? I will give an overview of the main routing widgets available at RipeStat. We'll look at the looking glass. I will talk a little bit about it. I will also talk about RS Live, BG Play, RPKI data, widgets, and we'll also learn how to use raw data that we publish. And some words will also be said about the new UI. Okay, routing widgets. We have many of them at RipeStat. And I think it will be more interesting for you to look at RipeStat rather than just the statically stored widgets. This is the landing page of RipeStat, and it all starts with the search in the search bar. You can enter anything that's related to the internet, but we are interested in routing. So let's use the prefix that the system is suggesting. And all routing widgets are in here, in this folder. It's called routing. Well, the widgets themselves, what was the idea when they were created? Well, the idea was that you would be able to use them not only, or rather, you would be able to view the information not only at the RipeStat page, but that you could take the data with you to your own page, to your own site, to your own wherever. And this is what happens when you place all widgets on the same page. The idea was that you can place widgets one by one, and over here, embed code, you can find the HTML code that you can use to take these widgets with you to your own page. Another thing that you should know about the widgets, well, first thing, it's not really convenient to have all of them on the same page, but if you select a particular widget, they will open in a particular page. If you want to see routing status, you click on the routing status, and you will see a page containing only the information from this widget, and this page obviously can be uploaded and processed much faster, just because it is the only page. But let's go back to the list. Routing status shows you the main information about the prefix of the autonomous system that you searched for. And you will be able to see its current status. Can we see the announcements of this prefix? If this is an autonomous system, then what are the visible prefixes? And what is the RPKI status? In our case, it's green, which means everything is fine. We have we see that the announcements are aligned with this record. BG Play. BG Play is an interesting widget because it shows the interaction between autonomous systems, and it visualizes paths from as a graph. but we'll talk about it in greater detail, and I will show you what you can do to get information on BGP Play in a more readable format. BGP update activity shows you the number of BGP records at the prefix that we are viewing. It must be noted that those messages come from all route collectors, and we have 21 of them right now. They are located around the world, and they are collecting information from about 1,300 connected users. Not all of these users return full tables. Some of them provide us only with partial tables, but those of them who are returning BGP full view, those are the tables. That's the data that is used in most of the widgets that Ripestat. In most widgets, you can enable and disable information. Okay, that is to say, do you want to see the data that could be seen only to a few peers, or you want to filter the prefixes that can be visible to several peers that could be visible only locally? In this widget that the BGP update activity, we see the number of announces and withdrawals. In total, among all RS participants, risk participants, for a given period of time. In our case, it is 1 hour. As you can see, the number of announces is quite big. It's about 50 an hour. And that tells us that some participants are constantly updating their paths or routes to this prefix. Many widgets also give you an opportunity to change the time frame. Over here, the time span is 2 weeks, 14 days, but you can make it shorter or make it longer, and then the scale will also change. Another interesting widget, browsing history. Usually this widget uh, also takes a lot of time to produce the data, and depends on the prefix and the autonomous system that you are trying to reach. And if you reopen it, in our case, our prefix is not being announced for a long while, and it's not been announced actively. Over here, you can see the timeline at the bottom. To the right, you can see the announced prefixes, and it's not just the prefix that was searched for in the search bar, but also certain special prefixes. In our case, we see that our autonomous system only announces the slash 48 prefix, but for a while, we could also see announces of slash 12 or the slash 32 prefix. That was a long time ago, back in 2010. So sometimes it is useful to get this information on how the prefix was announced in the past. The color code shows you how many RS priest members saw the announcements of the prefix that we are looking at, and it's the peers who return the full BGP feed to us. At the top of the peak, we had 352 peers. That's the number of the members of RIS who return the full BGP view to us. Let's go back. BGP Looking Glass. Another useful widget that helps you quickly find faults in the BGP system. And it was the original idea behind RIS, actually, when we only were planning this uh, system around the year 2000. We thought that we needed a BGP Looking Glass that would be looking at different BGP routers and that would be gathering data from a distributed network of routers that at that time we had in different parts of the world. Let me open this widget. Properly. We have 21 of them. You can see the list here at the heading and the header, and you can enable and disable. What is the information that can be seen? If you just a second. If you open up all the RSCs, you can see that our prefix is uh, seen from our autonomous, it's visible from our autonomous system, which is great. It means that no other autonomous system is trying to intercept our prefix. But when you are trying, to do troubleshooting, if you are trying to or find the fault and see how your analyses are seen around the world, then for each collector, and then for every peer who sees the analysis, we are decoding basically the BGP record, providing more information like the time of the announce, the ice path, and the community. What else is there? Over here, you can see two types of time, last update and latest time. What's the difference? Last update is when we got the last announce of path to this prefix, and the latest time is the time before which we processed the message from this peer at this collector. Next widget, visibility. It's a shorter version of Looking Glass. It shows you in relative and absolute terms how visible your prefix is to the peers. RFC 00, RFC 00, 58 out of 59 peers can see the collector 00. Its visibility is 98%. Other collectors have a visibility of 100. It looks like its visibility is quite high. Related prefixes. For the prefix that we searched for, there aren't any additional prefixes, but if there are announces that are specific or that are associated with the prefix that you searched for, in this widget, you can see the information about the prefixes that are somehow related to the one that we're looking at. Prefix routing consistency, another wonderful widget that shows you the information from different sources on the paths to that particular prefix and how much it matches between those different sources. We've got information from RIS, which is compared against information in uh, internet routing registries and from the RPKI. What are we looking at right now? This prefix is known to RIS, it's visible there, and the autonomous system is described in the same fashion at IRR. It's the same path. We don't have other IRRs who would see that prefix in RPKI. As you could see the overview, the information in raw is the same as what we see at RS. The prefix from the perspective of our RPKI, the path from the perspective of our RPKI is valid. Next widget. This first last thing is disabled right now. It's being maintained. It's in maintenance, but we hope to bring it online very soon. But right now, it's not working. And the last one on this page is upstream visibility. This widget shows to you which other autonomous systems our announce uh, follows, or through which other ASs it goes through. 6939 takes the majority. Here, it tells us that about 60% of kids can see the prefix announces via the 6939 autonomous system. And then in percentage terms, you also see the distribution between other autonomous systems. And you can get not only current data, but you can also select timeline for now. It's 1 day. And you can see that probably at this point the routing table was changed and 6939 started taking greater share. Probably some peers lost connectivity to our prefix, but later it was restored. What else is there worth noting? Actually, we have seen only 10 widgets, but we have many more of them. It's a long list. The link can be found on the slide. If you click on this link, you get to the list of all available widgets. Looking glass. In addition to what we have already discussed with respect to looking glass, out of all RipeStat widgets, the data in the looking glass are most up to date. Usually the latency is less than 1 minute for 95% of all peers in the RIS. The data in other widgets have a longer delay. For them, latency is on average 6 hours. But of course, it depends very much on what kind of widgets we have in mind, or what kind of widget we have in mind, and what kind of data it provides. Another system that shows you these are very much in real time is our RS Live project. You can see the messages in real time streaming, basically. You can see the messages live, and you can process those messages in real time. RS Live is not a widget. It's not like the tools that we saw before. This system requires some coding in order to process data that can be obtained through this RS Live system. You need to do some programming. What you're looking at right now uses JavaScript. It's quite a simple case, and it shows you how you can use the system and what its main capabilities are. First of all, the information is provided as JSON. As you can see here, if we stop the stream, then the data is quite readable. Even that is enough to work with the data. If you call your own client, then you can also receive binary full PGP messages and process them yourselves. But again, JSON is more than enough for most operations. What else? To be efficient, you need to limit the information that you are receiving. We already have quite a number of fields that you can use to filter the information to set limits. You can use prefix, or you can use AS class, or you can use the type. If it's a PGP update, you can look at announces or withdrawals of class. You can look at specific prefixes or the ones that are related or more or less related to the one that you are searching for. You can also look at different collectives, all of them together or individually. And you can also analyze information coming from a particular peer. That information is transmitted via WebSocket. So it means if you need to code an application, you can use a ready-made application that knows how to deal with WebSockets. There is nothing difficult in it. The example that is shown to the right, uh, well, that's how much JavaScript code you have. And like I said, there are already available apps for clients. One of them, BGP Alerta, is probably one of the more popular. There's a link to it in the presentation. BGP Alerta provides you with alerts in real time on your prefixes when they are being announced from a different AS or when they're being announced with some other parameters, or you can also select to receive alerts when those prefixes are seen with a status not matching RPKI. This is an interesting project. It's become quite popular, although it is relatively new. There are two more projects available on GitHub. They are written with uh, And one of the authors was speaking at ENOG recently, and he said that it took him almost no time. That was Jared Mauch, and he said it took him basically no time, and it was easy. Well, this life is quite an easy to understand framework that doesn't require much expert knowledge. PGPlay is one of the more popular and well-known widgets at Rhymestat. It's been around for a while, and it still hasn't lost its popularity. What does it show? This graph that I'm um, explaining here to the right. It's what you will most likely see when you launch this widget from Rhymestat first page. It it is a view of a prefix at a particular time. It's interesting to use a widget when you already have an idea that something interesting happened to a particular prefix at a particular time, and you want to examine that case. If you just start this widget without a reason, uh, it will not tell you much. It's not very useful, but I will give you an example that involves these beacons, or as beacons. What are beacons? They are signal messages that we are sending from our collectors to make certain measurements and to examine how BGP messages propagate, how they spread. So what happens? We announce certain prefixes from all route collectors. We publish the prefixes and which collector, and we announce them at particular time intervals. And then we would de-announce those prefixes also at certain time intervals, which allows us to analyze how reachability or non-reachability of those prefixes, or rather the information about the reachability, spreads out in the internet. Let's take this one, RRC00. This is the prefix that we announce and then later de-announce. And we announce it like I said, with a certain time interval. Every 4 hours, there is a shift of 2 hours between announcement and de-announcement. 0 hours, the prefix is announced. At 2, it's de-announced. At 4, it is announced again. At 6, it's de-announced once again. And what do we expect to see in the Bishop Play and the internet is when we de-announce the prefix that's not visible anymore, and after we announce it, we expect it to become visible everywhere. Using Bishop Play, we can test this hypothesis. Is it true that after the prefix is announced, it's visible to all peers? Is it true that once it's de-announced, the peers, all of them, stop seeing that prefix? But before we see the results of this test, a couple of words on the widget itself. Just like other widgets, it's more comfortable to work with it in a dedicated screen, one widget per page, and that's why we have this little uh, button that can maximize and minimize the widget. And also, the widget itself has the information screen that in this field you can find uh, information about the time and date and the information about the BGP message that we are viewing right now. And most of the screen is taken by this graph. There are a lot of dots on the graph. Every dot, every circle is an autonomous system. The blue ones, the blue dots, they are autonomous systems that are peers of our RIS network. The black ones are intermediary autonomous systems. And if you point your pointer to one of those autonomous systems, a pop-up window appears providing more information about this autonomous system. In red, we see the autonomous system that is the source of the path that we are currently investigating. It must be noted that you can have several red dots on your graph, in your graph, which might be indicative of a problem. A prefix could have been hijacked. Sometimes this is done on purpose, and it's not an accident. And one other thing, you can see there are no links between those autonomous systems. At the time, this time snapshot that we are looking at, none of the peers are seeing any paths to the prefix that we are researching. Below, there is a timeline, or actually two timelines. The first one shows you the full time period that we are studying, and the timeline below shows you individual BGP messages in a greater time scale. Those BGP messages are shown in different colors depending on the type of the message. Green is an announce, red de-announce, orange is announces the change the path to the prefix. What else is there? Another pop-up window that enables you to set the search parameters. The most interesting ones are probably the times, again, that's not the end date, and the collectors. The collectors that we want to use for our graph. And we can select all of them. And we can also disable re-announcements because right now we are not concerned with re-announcements. Okay, so if we change that information, okay, all the data is retrieved from our server. Oh, another thing, all widgets in LiveStat below over there, they have the source data. If you click it, you will see the data on which that widget is based. RipeStat API is the foundation for all widgets. It's this data that we visualize, and you can also use RipeStat API for any purposes uh, that uh, you pursue for monitoring, for visualization, for anything. And that button will show you which RipeStat API inputs are used for this graph. So we uploaded the widget again, we uploaded the data, and we can see that at this time when we are at the start of the period that we identified in the settings, which is 17 minutes to midnight, and this is the period when we can expect that all, or well, at least from our collection, we de-announce the path to this prefix, and we expect no one to see any paths to our prefix. But we can clearly see that there is at least one path, and you can use the pluses and minuses on the left side of the screen, or you can use your mouse to change the scale of this view to find out which autonomous systems are involved. 2914, for some reason, that peer has not denounced the path to our prefix and keeps announcing it. And this is exactly the value of this widget, the Reese beacons. That's the data. And if you read the next message in the same time period, and that's when we start announcing our prefix 1 second after midnight, we see that if we play back the messages, we'll see how slowly, gradually, the peers are receiving information about the reachability of our prefix. And you see how paths have been restructured, rebuilt to the prefix. Right now, I'm viewing the messages one by one, and we can see from below that those messages are coming in big chunks. Over here, they're grouped at the interval of 1 second. It means that the information about the availability of our prefix spreads out quite quickly, and the peers become aware of it quite fast. If you play it back automatically, you see how many more that many more peers are receiving this information, and the paths are rebuilt because some paths become more preferable than others for whatever reasons, by whatever parameters. What else can we analyze here? Well, we can analyze how fast the information about our prefix propagates across the internet. If we stop the playback and if you take a look at this bottom timeline, 12 seconds after we started announcing, the information still continues to spread out in big groups. And what we might be interested in further is when this information, or rather its propagation, slows down. And probably this is somewhere here. This is when we see when the interval between messages increases. This is 13 seconds. No. This is, we're too far down the road. We need to go back to somewhere here. Yes, this is what I was looking for. 45 minutes is the time between sequential messages. It means that previously messages were coming in groups, or here, for instance, when the interval became 7 minutes. What does it tell us about? What does it mean? This is 4 minutes after midnight. This is when we receive that message. The information about availability of our prefix was spreading out, it was changing for about 4 minutes. And in 4 minutes, the propagation stabilized. Then 7 minutes, it did not change. And then there were some changes to 11 minutes. And then for 45 minutes, nothing was changing. So our server information became stable 11 minutes after we announced it. What else? We see that at this point, some topographic changes in the network took place, and one of our peers announced a new path to our prefix. And again, for 1 hour, the information it did not change. The next um, milestone is 2 hours and 4 minutes. This is when we began to announce information about our prefix, and here we can trace how all peers in the network will start receiving the information how this prefix is no longer available. So what can we tell? Well, we see that the information does not spread out instantaneously, and like we saw in the beginning, the messages that we are receiving, they are all about the changes in the route to our prefix, but they do not de-announce our prefix completely until we start seeing red bars on the bottom timeline. A considerable amount of time passes, and before it happens, somewhere here, this is when we receive the first message that our prefix became fully unavailable for one peer in the network. A lot of peers are still capable of finding paths to the prefix. To them, the prefix is still reachable. And then you can also calculate how much time it takes to de-announce the prefix in the global network. And it's been already 25 seconds after we started de-announcing. The information is still out. The peers see that there are some changes in the information about the prefix, but let us speed up the process. Let's do this. We can go directly towards the end of this peak or the upper timeline, and then we will be able to see the intervals between those um, events. The information continues to change quite fast. At this time and here, this is 9 minutes after we started the announcing, yet we still continue to receive messages that the reachability of our prefix is reducing. And at the same time, we still have quite a number of peers who could still find paths to our prefix. You can select a particular path. You will see which autonomous systems are still providing paths to the prefix. And then this is the time. You can find it. This is the time when there are no longer any messages about availability of the prefix, and we see just one visible path to our prefix. Yes. Now, it's interesting. This is 41 minutes after we started de-announcing. 41 minutes, there is still one visible path to the prefix. It means that not all peers in the network got the message, that they are aware that the prefix is no longer available. It took 41 minutes. To me, that sounds like a lot of time. What I find interesting as an idea for a possible study, you can, for instance, research how the average time changes. Uh, the time after the announcement and before the withdrawal, and how this time was changing in the past year. At Ripe Labs, we have an article. We had a similar study about 5 years ago, and this information propagation time was about 40 seconds, 40. But you can see that now the time can be much, much longer. And if you analyze those surges, subsequent ones, you will see that on average today, this time is 2.5 minutes. In this particular case, it is 4 minutes. Here, 6 minutes. And still, there are some available paths. But this is when we expect our prefix to no longer be reachable. So if any of you are interested, we would really appreciate you running such a study because all the data for previous years is available. You can take the data and write an article. Now, what we have just seen is when, you can take RS beacons and use them to see how much time it takes for the prefix to be fully online, to be fully reachable and fully not reachable. We also have other beacons that allow you to emulate any cast prefixes. We have a prefix that we announce from two collectors. One collector announces it all of the time, and the other collector denounces it from time to time. And this allows us to trace the information on the reachability of our prefix. Actually, what we expect to see is that the information never disappears completely. At any point in time, our prefix should be available. It's just that the path should be reconfigured. And I have already prepared and uploaded the data on this prefix. Save us time. So we start at 10 a.m. and we can see that information about our prefix is available. There are many peers who see routes to the prefix, which is something to be expected. And then at 10 o'clock, as you can tell from the timestamp, the information begins to change. At 10 o'clock, it is announced from two collectors, and what we would expect to see is that some peers will start changing paths to the prefix because they will find more optimal routes. And then this is visualized. We can tell which peers now become the nodes in the process. Nodes in the process of disseminating the information. It's 2914. That's one AS. And I think I will fast forward towards the end when the information has more or less stabilized. We see that the uh, paths to our prefix are spreading out via 29, 14, 67, 62, and probably it's this one, 1299. And also 19151 in the United States. And now we can match this picture about which autonomous systems spread the path to our prefix with the information that we received between those peaks. When our prefix was announced, only from one collector. And we can tell that the picture looks slightly different. What we have now is most roads are leading to this 1103 SurfNet node in the Netherlands. Now, what was happening? During that peak, information started propagating from collector 3 in Amsterdam and collector 14 in the United States in Miami. That's why at this point in time, we can see that our Dutch transit provider was prioritized among other peers in receiving the information about the availability of our prefix. And when RTC3 stops announcing it, and the announcements are going just via the Miami-based collector, this Dutch autonomous system disappears from the graph. And you can see that this American node becomes most popular for raising awareness about the reachability of our prefix. What else is interesting here is those red messages here, those red bars. These are the announcements of our prefix. This is something that we would not expect to see because our prefix is constantly or should be constantly announced at least by one collector. But there are some points in time, some intervals in time, when some RS participants or members cannot see any path to our prefix, which might be indicative of a problem. In order to analyze this, to find out whether indeed we have a problem there, I will need to dig further and see whether following the D announcement, there is an announcement from the same peer, or maybe the peer just disconnects fully and completely. And then for us, this should not be a problem. In order to do this kind of stutter analysis, it can be done with BGPlay, but it's difficult. In BGPlay, you will have to review a lot of updates over long periods of time, which is, well, this widget is not intended for it. But this kind of analysis can be carried out on the basis of raw data, and this is what we recommend that people do. Of course, this is not the only option. It could be a different problem. Well, that is to say, you might want to use the raw data in other instances as well. And the raw data is gathered by our collectors with full access to the information contained in BGP messages. Raw data can be found at data.peace.tribe.net. The files are in the MRT format. It's a well-known and popular format of PGP data, and we publish this data in, or rather, there are two types of data that we publish. There is RIP dumps, the routing table status stays for every 8 hours. Midnight, um, uh, to 8 to 6, etc. And also there is BGP updates that are grouped by 5 minutes. And we call this file format update. If you go to our page, the description of raw data, you will see that it is grouped by collectors for every collector. And there is a file directory, and then the files are grouped by months. Every month, inside every month, you will see update files grouped into pieces of 5 minutes. And RIP dumps B view, those B views for every 8 hours, every 8-hour interval are also available. To go back to our BGP play example, one of the last peers, if I can find it, but uh, actually what we can do is we could take the announcement in this picture. It is something that we wouldn't expect to see. A complete disappearance of the route to our prefix. And if we want to analyze whether this is an accident and a one-off issue or it's a serious problem, then what we need to do is to see whether after this D announcement there is an announcement to our prefix. How do we test this? We must find out who of the peers de-announced our prefix, and this is this peer, 79143, and here the first digits are the number of the collector. That means that we need to download the file from the collector 00 that matches this time period. So we go back to the list of all the files. We find the 00 collector, and then we're interested in 6 a.m. of the 4th of November. The list of files is quite long. Okay, this is the 4th of November, and we need 6 a.m. Here is the file. I'm going to move it here. And now I need to share a different screen with you. There we go. In this fashion, we can retrieve the information from the files that RIPE publishes. You will need a tool that knows how to read MRT files. There are several tools around. The best known is probably BGP dump utility, which is supported by RIP NCC. Some time ago, BGP scanner was released. It's faster, and it can also filter. It works quite well for MRT files. And then there are also libraries. Virtually uh, all programming languages have libraries. Over here you can see MRT path is parse is for Python. There is another one. Go. Yeah. But what I did or and didn't do, I should have shared a different screen with you. I would go back. Yep, that's right. So once again, like I was saying, you need different tools. There's BGP dump, BGP scanner, MRT parse, and Go MRT. All the links are in the slides. And BGP dump and BGP scanner are available in manual Linux and in Unix distributives, and also for macOS. I will show you how BGP dump can be applied to this task. I will make it bigger. Okay. I have already uploaded several files, but we're interested in this one that I uploaded last. The files are binary. You can use a viewer like, or it doesn't make sense to use a viewer like this because this is how they look like. Instead, we should be using BGP dump. How does it work? What I recommend doing is always use a might speak flag because it logs to std error. If we want to find an anomaly and if BGP dump cannot parse the message, we would like to see it in any case and not be looking at this log. And secondly, I recommend using -m, either small or capital M, to switch between few modes. You can see this one to the left is quite detailed, or you can also output the value of all the information as a single line. And this is an example I'm showing in the right hand part of the slide. In order to analyze all messages, I would prefer the first option when all information is not like compressed, like compacted into a single line. Instead, you'll be able to see more message types, like live messages can only be seen in this expanded format, not in the single line output. And when it's expanded, information becomes more readable, especially if your idea is just to review data without analyzing it. But to view information from specific peers, I'd say it would be more interesting to produce a single line output. And what we see right now is the message type. They will have the GP4MP label. The time is seconds from the 1st of November 1970, the standard unit, the standard time used in the Unix systems. Then the type W means withdrawal, D announcement, A is announcement, next field is the peer, the member of the network from which the message came, the autonomous system of this peer, and then the prefix. In this case, it was de-announced. If it is an announcement, then in addition to the prefix, you will also get additional path from the PGP message, like IS origin, next hop, local path, if I'm not mistaken, and other additional attributes like community, if there is a community, and other information. What we wanted to find out in our case, if you still remember, we wanted to understand whether this D announcement is the last status of that particular peer. So we found out the address of this peer. We'll copy paste it in here, and then we can filter out all messages in those five minutes to get all the messages that we were receiving just from this peer. And now you are looking at the messages just from this peer. There are still quite a number of them. So the next step, we can also apply the prefix as a filter. And our prefix is 84205 72 0. This is the prefix from which we started at BGPlay. And now, what do we get? During those 5 minutes that came to our attention in this file, there was just one announcement and one withdrawal of the path to our prefix. So it looks like this route to our prefix was not restored. But to make sure, we can take the next file because this file only gives us messages from 06 to 0605 minutes. But we can also download the next file between 6 a.m. 5 minutes and 6 a.m. 10 minutes. We only have to change the title, the name of the file, the command line, and we see that no messages from this peer on the availability of our prefix are coming in those 5 minutes, which probably points to a problem because this one definitely lost connectivity to our prefix. So this is one way how you can use RIS raw data in your studies, in your investigations. Okay, so let's continue. RPKI. RPKI is a hot topic these days. We have 4 widgets to display information on RPKIs. It is used less for troubleshooting and more for statistical purposes. It is more academic, it is more global, so to speak. RPKI by AS. RPKI of an autonomous system. We can take the C autonomous system that shows this widget shows you the number of IPs for IPv4 prefixes. This is validated, correct, signed raw objects or prefixes. We used to have 8, and now we have 6. And since we do not announce many prefixes, it looks like that's all of them. But you can switch between prefixes of IPv4 and IPv6. You can see that we've got 2 IPv6 slide prefixes. You can use this widget somewhere in your monitoring system to keep an eye on various autonomous systems. RPKI by Trust Inc. It's an even more global widget. It gives you information on the correctly signed prefixes of the Trust Anchor. The Trust Anchor for this widget is the Trust Anchors of all mix of vibrancy, phrenic, Aryan, lactic. And you can see here this curve going upwards, and additional information can be provided. You will see how many signed prefixes each of these registers had at any particular time. RPKI by country. This is information that will be difficult to find in other sources. Trust Anchor, you can use your own validator, but for countries, this is probably your only source. This is aggregated information for a country. Geolocation is taken out of regional registries publications. From them, we get information on the geographic location of the prefix, and based on that, we calculate the number of directly signed prefixes for each country. And the calculations are the same. Again, you can get data for IPv4 and IPv6, and also in absolute or relative values. Out of the Ukrainian prefixes, for instance, 12% are IPv6 of IPv6 prefixes are signed, and in IPv4, recently there was this surge. It looks like someone signed all the prefixes, and now we have more than 25% of IPv4 prefixes signed in the Ukraine. AS routing consistency is a non-specific widget. That is to say, it's not specific for RPKI, but it also relies on RPKI data. In this last column, this is source data for prefix announcements. What else? What else should I tell you about? Well, I guess I should mention the new types interface. The interface that you've been looking at until now is the classical version. This is how it is known around here. And the new types interface was presented, a short time ago at the last RIPE meeting, and tomorrow we plan a session to launch this new interface at ENOG. It's going to take place 1 p.m. Amsterdam time. It's the first session of tomorrow. Join us. There will be a presentation on how to use this interface. From me, you can only get some previews. This is a teaser for tomorrow. What are the main advantages of the new interface? I would say it's become more compact and it's become more concise. It's um, now better viewable on mobile devices, and you can also create your own pages. And together on that, the widgets that you use most often. And it's possible now to do it on your own website. Instead, you can create your page here and bring all the widgets there. You can also do settings of those information maps, as we now call them. You can populate your screen with the data, with the information that you find most exciting, relevant, interesting, and you can also create several pages, actually, not just one, so that you can, have different widgets at different places for different use cases. And to go back to my slides. Oh, actually, we've reached the end of it. That's everything that I wanted to share with you today. Do you have any questions? Is there anything special that you would like to ask me, or that you would like to ask me to show to? I don't know how much time is left. I don't know. Well, essentially, we're supposed to have 2 hours for the session. So basically, we have a lot of time. And we also have questions. Ilya, I see a question from you. Do you want to use your microphone? If not, I can read your questions. Okay. Ilya seems to be reluctant to enable the microphone. Okay, let me read it. First seen, last seen, and the API. And there is the first 16 block. How do you find out which all the prefixes were announced historically? In the API, can you send a request about specific prefix, but without recurring variations? Because you can have a lot of variations of 16 prefixes. I think you, I mean, I'm sure you know the answer. Okay, if you want to find out which prefixes were announced historically, then this is the widget that you want the routing history. It provides you with exactly this information, and it can be more specific or less specific. The nested prefixes and the enveloping prefixes, if I may use the word. Over here, you see I made a request for this prefix /94, but over here, you see all other prefixes that were announced during all of the time for which we have data. Some of them are more specific, some are less specific, and on the timeline, you can see exactly when they were announced. So if you're interested at this /24, then it's here, and we know that it was announced first on the 13th of May 2018, and before that, over here, it was part of a /23 announced somewhere from 2010, September 2010. And here in the source data, like I said, the link to the API request that produces all of this information. And you have answered the next question that they just sent us. Is it possible to find out how actively, how intensively a particular network And what are the indirect signs of that? Well, you've just given the answer to this question. Is there anything else? Anybody? Well, no questions. It means that everything is absolutely clear. And if the audience was not familiar with any of the tools before, they was not using all of them now, actually. Well, if time permits and if there's interest, I have another use case. Well, we definitely have time and we definitely have Ilya who's interested. Okay, then here goes. There was this notorious case. It was a massive attack to steal passwords of the users to one cryptocurrency website. It was my wallet, my Ether wallet. And this attack was quite uh, composite. It was quite complex. And why I like it so much because it's the right way to use BGP hijack and other technologies in order to perpetrate such a competent attack and be productive and succeed. So what was the case? On 24th of April 2018, between this period of time, it took less than 2 hours, in fact, the autonomous system 10297 announced 5 prefixes that belonged to Amazon and that hosted the authoritative DNS services for Route 53. It was a DNS for the users of Amazon Web Services. As you can tell from this example, this one actually, one of the prefixes that was announced by this 10.97 autonomous system is the prefix for which I made a request, this one /24. But at the time that we are investigating, which was 24th of April 2019, over here in this widget, you can zoom into this timeline, and you will see that as of the 24th of April, which is roughly here, this prefix was announced by Amazon as if a slash 23, as a slash 23. And then here, yeah, but this is Amazon too. Anyway, you don't see a slash 24 announcement by this autonomous system that perpetrated the attack. Why? Because for this prefix, this data is used that is collected every 8 hours. That's why we do not see the announcements that lasted less than 8 hours. Something to bear in mind. Many RS widgets have a minimum resolution of 8 hours. The events that lasted less than 8 hours will not be displayed. They will not be visible. However, if you go to BGPlay, where is BGPlay? BGPlay for this prefix and for this time, it collects and accumulates information from RIS dumps and updates, and it can reconstruct the initial state at any point in time, and after that point in time, it will display all messages. So what we can see is that at this time, none of the autonomous systems after this period that I've selected, and this is the time period of the attack. During that time, none of the RIS peers did not see any paths to the /24 prefix. And if you go back to the first message from this time period, we'll see that 10297 autonomous system started announcing the availability of this prefix, and it was called by 6939 electric, which seems to be providing transit for this autonomous system. And if you play back this message on, you will see that all other peers are receiving the same input from 6939, and the prefix that we're looking at, the /24, becomes available not everywhere, but to enough peers. Like here, we now see a path to 4608, and this is APIC. And then, after a while, after 2 hours, almost 2 hours, this error was identified somehow by either 6938 or by 10297, and the path to this prefix began to disappear. One other capability which you play as a widget, you can also change the speed of animation. You can, go through this faster. You can play it back faster, and you see towards the end of the timeline, the path is totally announced, and the time when the when yeah, at the end of this timeline, the situation was fixed. There were no more announcements to the system. End of April, it looks slightly different. We see more autonomous systems that are involved during this time frame. And this is until the end of April, like I said. You can see that there are several autonomous systems now that are marked here in red. This is origin S. All of them announced this prefix. And in addition to 10297, that was so from the very beginning, there are now 2 more autonomous systems that belong to Amazon. And those messages, right, that we saw first there in the beginning, announced by 10297, then they all disappear. No one sees that prefix, but here, probably this is when Amazon decided to take care of this potential hijack of its prefix, and they started announcing a different prefix, not the /25. Instead, they deaggregated it to all /24, and not just this prefix, but other as well. They started announcing the /24 prefix here, and maybe the they also changed the announcement from one S to another. So this can be nicely visualized in the VG Play widget. It's a great application. Yeah, I agree totally. Now, what else? Um, this BGP hijack, as it turned out, was just part of the attack. In order to impersonate authoritative DNS servers, and those fake servers, they were activated, and they were returning queries only for my user wallet. And other domains were returned as failed. While my user wallet.com returned 46.161.42.42, and if you search for this IP address, it was announced as part of the prefix, this one, 42.0/24, can also see how it was announced during this attack. And probably will not see anything special. Visual play. Those routes between autonomous systems, they are either displayed as a solid line or as a dotted line. And a dotted line shows you the static paths, the ones that stay the same throughout the time period that we are investigating. You can see that throughout this attack, the path to this prefix did not change much. There is only this one that was changing somehow. Or it looks like, well, it didn't change much anyway. What is interesting is that this path from origin AS to the autonomous system that started spreading this information globally is quite extensive. And by the way, if you are using video play in different cases, you will experience notice that this is quite rare. Out of 4 autonomous systems, well, we have 4 autonomous systems that do not announce this information to anybody else apart from themselves. It's quite a long chain, but this is a rare case. It's not often that you see such an arrangement in which you play. Those autonomous systems, again, if you scrutinize them, you will understand that this is quite an unusual path. The autonomous systems and the systems that announce this prefix is registered in Russia. The next AS is registered in the Ukraine. The third one in the Ukraine again. The fourth one in Russia again. And then it gets into this AS 9002, which spreads it out into the global network. And if this information is interesting to anyone, then you can use it as your starting point in an investigation. Routing history and BGP replay widgets. Both links are here. You can also read a report. I think it was Doug Maturi who published this report, in which he demonstrates that the path, these 3 autonomous systems, apart from the last one, which has a different origin, were also engaged in a different attack, which first used a BGP hijack and after that DNS impersonation in June 2018. It's an interesting publication, which I highly recommend. And that is the end of my story. Thank you very much. Do you have any further questions? Yes, I will be happy to take our other questions. Well, anyway, colleagues, the slides will be on YouTube, ENOG webcast users. You can watch this presentation or previous presentation, and you can also have access to the recordings from previous ENOGs. The slides are published on the website. You can go to the conference website, and also on the website you can rate the presentation. Please leave your feedback. It's important for the program. Committee, all your comments, all your remarks are invaluable to us because we always refer to them while preparing the agenda for the next conference. So, again, we ask you not only to participate in the conference by watching the presentations, but also to participate in the future conferences by rating the speakers, by rating the slides, the presentations, by letting us know what you find interesting, useful, and important. Well, as it turned out, the presentations are only available in the English page of the conference. On the Russian page of the The links are not yet available. Well, I'm sure people will take care of that. Okay, for example, the Russian page is updated manually. That's why. I mean, if you want the PDF file right after this conference, I refer you to the conference page. The English section, the Russian section will be updated a bit later. These are my contact details. Again, I will be happy if you got in touch. Yes, well, thank you very much, Oleg. And before everybody leaves, let me remind you of the agenda tomorrow at 1 p.m. Amsterdam time, which is 2 p.m. Kiev time, which is 3 p.m. Moscow time, 5 p.m. Yekaterinburg, 7 p.m. Novosibirsk time. Tomorrow we start with first the session of the interface. After that, there will be a coffee break at 4 p.m. Moscow time, 3 p.m. Kiev time, 2 p.m. Amsterdam. The main plenary session starts. We begin with a former chair and current managing director of IPNCC, Hans-Peter Hoden. He will talk to us about the latest developments at IPNCC, and hopefully he will also say a few words about the vision of IPNCC or for IPNCC in the future. At 3:50 Amsterdam time, 4:50 Kiev time, 5:15 Moscow time, there will be quiz again. Come and have fun. After that, there will be two more presentations. One on task force organized by IPNCC on how the board of directors of IPNCC should be elected. And after that, there will be one more presentation on the core business of IPNCC, actually, all the registries, registry services, and registry accuracy. If you have IP addresses, autonomous systems, or if you are interested in internet governance, then tomorrow is the day for it. Please join. Do not forget to leave your feedback and rate presentations. It is truly important for us to be there conferences, and please stay with us during the week. Thank you very much. Bye.